This panel runs the light in the ho-ho. I press the switch on the wall, and the light does what I tell it. Now you may think there's a Raspberry Pi in here, or some smart home hub. There isn't. The thing running all of this is a single chip. An ESP32, the same one you will find on a hobby board that costs a few dollars. It's just a row of tiny logic pins. Each pin puts out 3.3 volts and can simply handle maybe 20 milliamps. The main board wants 220. Cannot wire either of those to these pins, no safely, no jerkily. The whole job of this board is to build that chip up into something an electrician can actually use. Step 1. Outputs. Each of those pins run through a driver and becomes an output that can switch a real load, and those outputs are MOSFETs, not relays. A relay switches with a mechanical contact that physically slams shut. The MOSFET is a solid-state switch, no moving parts at all, silent and nothing to arc or wear out. Honestly, for switching lights on and off thousands of times, that's the kind of switch you want. For low-voltage DC lighting, the kind of strips and truck lights modern homes are moving to, that's exactly the right kind of switch. This board packs 16 of those MOSFET channels into one DIN-rail unit. Drivers and screw terminals are already done, and it is not a one-off. On the FeedCurrent set, the same family runs from 4 channels all the way up to 128, so it sets the controller to the job instead of stocking little modules. Everything on the control set, the board included, runs out of this one DC supply that reads about 12 volts. Step 2. Those MOSFET output a low voltage signal. But the real home has all kinds of loads. Same circuit, big ones, DC straight, old mains lights. So on the output side, I add a bridge for each kind of job. Solid state relays are trigger on anything from 3 to 32 volts DC and switch silently. A small plug-in relay rated 12 amps and 250 volts and a socket. So if the channel ever fails, you swap it in seconds without touching the main board. On the 25 amp contactor for the heavy stuff. A 4 main circuit, a bank of lights, a motor. To be clear, on this build, the plug-in relay and the contactor are not wired to a lamp. They're here to show the bridges the board can drive. In a real job, each one lands on its own fixture. Step 3. Inputs. Now the board can read the wall. Each panel wires the few switches to the inputs, sharing a common ground and where the 2 panels end. Step 4. The software, which is really the selling point. Let's flush the firmware first. Plug the board into your computer with the USB-C data cable. Go to the FeedCurrent set. Open the online flasher. Click Connect, type model, and then flash over USB. That's it, the board is ready to run on its own. This wall button switches are live. It's an if and a then. The 2 panels here are different kinds of switches, so their routes are set differently. The first one is a regular wall switch and holds its position, so it takes 2 routes. One for each state. Switch closed reads as true, and the light comes on. Switch open reads as false, and it goes off. The second one is a push button that springs back. There's no position to hold, only the press itself. So the roof is on the resting edge. Instead, it is pressed, and each press toggles the light. You can also trigger on the filling edge, the release, or on both edges. And the same menu goes further. Single, double, hold. The firmware taps you presses, so one button carries several actions. A tap for this light, a double tap for other, a hold to dim. One of these rules is saved as a scene. As your one home assistant comes in, there's the same mode switch right here. Turn it on, and the board pushes the scene into Home Assistant on its own. It just shows up here. And the same button is on my phone too. Rule 3. Add the temperature probe as a sensor. Set the condition to greater than or equal to 35 degrees. Let's see that output drops to the 25 amp contactor. Cooling the server room, but only when it's actually hot, never around the clock. I warm the probe with my hand. The reading climbs past 35, and the output kicks on. So every one of these reads lives on the board itself, a powered network cable. Right there, a panel switches the scene, the temperature rule, all it still runs. A $5 chip built up step by step, outputs, bridges, inputs, and a sensor, and the software, into a controller that runs a whole home's lights and does not need a cloud to do it. All of it on thin reel, ready for distribution box. What goes in a box and what stays out? That's exactly the kind of thing you want done by someone who's done it before. You're not buying a box, you're buying hours already spent. Link is below. I'm Yuan. This is FeedCurrent. See you in the next one.